In a universe that is just packed with these spectacular, show-stopping galaxies, some of the most important ones are actually really easy to overlook. Today, we're going to dive into one of those, a faint, kind of diffused galaxy that holds an absolutely brilliant secret. It's a key that actually helps astronomers map out our entire cosmic neighborhood. So, to really get a handle on our galaxy, first we need to know its address. It lives in what's called the M81 Group, which is one of the closest and most well-known galaxy groups to our own Milky Way. You can almost think of it like a bustling cosmic city right next door, and we're just over in the suburbs looking in. And when you think of the word galaxy, this is probably what comes to mind, right? These huge, majestic spiral galaxies with bright, beautiful, swirling arms. I mean, they're the superstars of the cosmos. They're the ones that grab all the headlines and, frankly, all the telescope time. But today, our focus is on this guy, Caldwell 3, also known as NGC 4236. And, well, visually, it's not exactly a showstopper, is it? It's faint, it's hazy, it's really easy to miss. But that unassuming, kind of boring appearance is exactly what makes it so incredibly important. So let's get the stats down. Caldwell 3 is a barred spiral galaxy. It's sitting about 14.5 million light-years away from us in the constellation Draco. And like we said, it's a member of that nearby M81 group. Now, the big reason it looks so faint is because of something called low surface brightness. It's pretty simple, actually. Its stars just aren't packed together very tightly. They're spread way, way out over a huge area, and that makes the whole galaxy look almost ghostly, kind of transparent. And here is the paradox. This galaxy actually takes up a huge patch of our sky. We're talking about half the width of the full moon. But because its light is so spread out, it's incredibly dim. And that weird combination makes it both a real challenge to see and, as we're about to find out, a perfect laboratory for science. And this is where that weakness becomes a massive strength. Because the stars in Caldwell 3 are so spread out, a powerful telescope like Hubble can actually see them one by one. They don't all blur together into a single haze. And being able to do that, well, that is the key to unlocking this galaxy's secrets. Okay, let's dive in. We're about to zoom way, way in. From the scale of an entire galaxy all the way down to the physics happening inside one of its individual stars. This is where the real secret is hiding. So when astronomers get all this data on thousands of individual stars, they plot them on a chart that looks like this. It's called a color magnitude diagram. Think of it like a stellar census. It shows each star's brightness plotted against its color, and its color tells us its temperature. Now, when you plot all the stars from Caldwell 3, this really clear pattern just pops right out. It's known as the red giant branch. These are older, aging stars that have already burned through all the main hydrogen fuel in their cores. As these stars get older, they basically travel up this branch on the chart, getting brighter and redder as they go. But then, right at the very top, they just stop. Full stop. There are no red giants brighter than this point. So why? What on earth happens right at that tip? The answer is one of the most sudden, most violent events in the entire life of a star. It's something that happens in just a matter of seconds, and it's called the helium flash. Let's walk through it. First, the star's core is just full of helium ash from all the hydrogen it's burned. So hydrogen starts burning in a shell around that core. This process puffs the star up into a red giant, while that helium core just gets squeezed tighter and tighter until it becomes what's called degenerate matter, a super weird state that's governed by quantum mechanics. And the thing about this weird matter is it doesn't expand when it gets hot. So when helium fusion finally ignites, it triggers a runaway thermal explosion. And here is the payoff. Get this. For just a few seconds, the energy that's released in that tiny little core is greater than all the stars in the entire Milky Way galaxy combined. It is an absolutely unimaginable burst of power, all happening deep inside one single star. But here's the crazy twist. You can't see it happen. Not a bit of it. All of that incredible energy is trapped deep inside the star, completely muffled by its outer layers. In fact, most of the energy just gets absorbed to change the core from that weird degenerate state back into normal matter. It's a secret, totally silent explosion. So here's the crucial point. Because this helium flash is triggered by fundamental physics, it always happens when the star's core reaches the exact same mass and temperature. That means that the stars at the very tip of that red giant branch always have the exact same true brightness. They are perfect standard candles, which is basically a cosmic yardstick for measuring immense distances. All right, so now let's see how this all connects back to the big picture. We can take this amazing secret of the stars and use it as a tool. By just measuring how bright these special red giants appear to us, we can calculate exactly how far away Caldwell 3 and all of its galactic neighbors really are. So what does this incredibly powerful new tool let us do? Well, it lets us transform our flat two-dimensional picture of the sky into something way, way more revealing. We get this, a three-dimensional map of the M81 Group. By measuring the distances to each one of these galaxies using their brightest red giant stars, we can finally see the group's true structure in space. We can see which galaxies are closer, which ones are farther away, and how they're all really arranged. And when we look at the actual data, we can see the results pretty clearly. While the heart of the group, M81, is about 11.8 million light-years away, our galaxy, Caldwell 3, is significantly further back, at roughly 14.5 million light-years. So yes, it is physically part of the group, but it's a distant member, just kind of hanging out there on the far edge of this cosmic city. So it all started with a galaxy that, let's be honest, looked pretty faint and uninspiring. But by looking closer, we found a secret stellar explosion that let us map our entire cosmic neighborhood in 3D. It really makes you wonder, doesn't it? What other profound secrets are just waiting for us, hidden in the dimmest, most overlooked corners of our night sky?